All right, here we go. Question 13 from our Precalculus homework number 12 in MyLab Math. They want us to solve the following system of equations using matrices with row operations. It says that the system has no solution, say that it is inconsistent. And so the first thing we're going to do is copy and paste our equations into our scratch work and get started. And so again, if you can see, I was lazy and I did actually just copy and paste that over into the scratch work. And the first thing we need to do is, we need to convert this system of equations into an augmented matrix. So taking the first row, we're going to have 3, -2, 1, and 3. And notice, I didn't mention it this time, but you do need to check and make sure that your variables are all lined up, because each column of numbers has to correspond to a specific variable. Next row, we're going to have 12, 9, 72, and 0. And for the last row, -3, 1, -5, and 1. And once we have the augmented matrix written, we need to start making our way towards row echelon form. All right, so I'm going to take a bit of an unconventional approach to the row operations this time, because I don't know if you're like me, you want to avoid fractions at all costs until the very last moment that you have to deal with them. So if I were to perform the row operations in the order that I have previously suggested, the first thing you would need to do is convert this 3 into a 1. No other x coefficient is 1. And the only way to achieve that objective, if you're going to work with the first row, is to multiply through by the reciprocal. And that would really F up the first row. That would really fraction up the first row. And so what I'm going to do this time instead is I'm going to get the 12 and the -3 to become 0 first, and then I'll go back and make the 3 into a 1. All right, so here's what I notice. I notice that if I take row 1 and simply add it to row 3, that'll produce a new row 3, and it will also get me a 0 where I need it. 3 minus 3 is 0. I also notice that if I multiply the third row, okay, now hang with me, I know this is unconventional, but if I multiply the third row by 4, -3 times 4 is -12, and then if I add that to row 2, it would get me a 0 where the 12 is, which I need. And that will produce a new row 2. Now I've written these backwards. I'm actually going to perform this row operation first, and then this row operation. Notice that row 1 here is not going to change. And so I'm going to copy and paste row 1 to begin with. So 3, -2, 1, and 3, copy and paste. And then to execute this row operation first, we're going to multiply everybody in row 3 by 4. -3 times 4 is -12. Adding to row 2 gets me a 0. And then we just simply rinse and repeat. 4 times 1 is 4. 4 plus 9 is 13. 4 times -5 is -20. -20 plus 72 is 52. 4 times 1 is 4. 4 plus 0 is 4. And that completes this row operation. And now we're going to do this row operation. So adding row 1 to row 3, 3 minus 3 is 0. -2 plus 1 is -1. 1 minus 5 is -4. 3 plus 1 is 4. And now we need to take an inventory, see where we're at, and then try to determine our next move. All right, after careful consideration, I have decided that I can turn this 3 into a 1 at any time. I can always just multiply through by 1/3. So I'm going to let him stay at 3 for the moment. And then the next thing I'm going to focus on is I'm going to try to get this element here to become a 1 like it should be. Notice that this element below in row 3 is -1. So if I could simply distribute a negative to that row, that would make that a +1. And then if I do a row swap, that would get me a 1 where the 13 is. Okay, so let me show you notation-wise what my goal is. Next goal, I'm going to multiply -1 times row 3, and that'll produce a new row 3. That's all I'm doing there is a row multiplication. And then I want to do a row swap. I want to take rows 2 and 3 and switch them. Now notice that row 1 is still unaffected. I'm not going to change row 1. So I'm going to start by copying and pasting the stuff that doesn't change, and then executing these row operations. First, multiplying row 3 by -1, and then swapping the rows. Okay, so here we go. -1 times 0 is 0, and then swap the row. -1 times -1 is 1. -1 times -4 is 4. -1 times 4 is -4. And then row 2 becomes row 3. 0, 13, 52, and 4. Next objective. Again, I'm still holding off on this 3 because I can change him to a 1 at any time. The next thing I want to achieve is a 0 where the 13 is. And now I can do that through row multiplication with addition. We want to multiply -13 times row 2 and add to row 3 to produce a new row 3. So here row 3 is the only row that's going to change. I'm going to start by copying and pasting rows 1 and 2. And now that that's done, we need to execute our row operation. Starting with -13 times 0, which is 0, added to 0, retains my 0. -13 times 1 is -13, plus 13 is 0 because I designed it that way. Next, -13 times 4. And then added to 52. That's going to be calculator worthy. So pulling up my handy dandy class whiz, we're going to have -13 times 4 plus 52. Oh, and that's 0. So that's going to give me a 0 in this position. That's a bad sign. All right, let's see how we're going to finish this. Next, we're going to have -13 times -4 added to 4. And again, bringing up our class whiz, -13 times -4 plus 4. That's going to give us, 56. So writing that down in our matrix, 56. And okay, so this means that I'm glad I didn't F this up. I'm glad I didn't fraction this up and have to deal with all the fractions, because this is a bad sign here. Anytime all 3 elements for x, y, and z go to 0, that's going to indicate either infinite solutions or no solution, depending on what this number is. So if I translate this last row back into an equation, that would say 0 equals to 56, but that's false. And so that indicates that this system of linear equations actually has no solution. Now the special word for that is inconsistent. If you remember back when I read the instructions for the problem, it said if there's no solution, put inconsistent. So now let's go back to the MyLab math and see what our options are. And back at our MyLab math, we can see that there was no solution. There's two choices for infinite, but there is only one option if there is no solution. So the system is inconsistent because we reached an impasse. We could not get to row echelon form, and the last equation that we translated was false. And so that's going to do it for this particular problem. If you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me, and thanks for watching.